that receive the data from the computer, translate it, and into the form of an understandable to the user and the another device. So they allow the computer to communicate with the user or the other systems, and there are many popular output devices. Normally, we see the output on monitors, and we take the printout using the printers, and we listen to the voice or else the music through the speakers. And suppose if you are having the projection system also attached, we use the projectors in order to output from the apart from the monitor, we can output the content that is to be displayed on the monitor onto the wall through the projector also. So as the input devices have their own memory called as the input buffer memory, here the output devices also have the memory called as the output buffer memory. So these are some of the output devices shown on the monitor. So some of them are the monitors, either it may be a CRT monitor, which is very old model, and then it may be a sort of TFT monitor. The printers may be laser printer, inkjet printer, desktop printer, whatever the case may be. And then there are the speakers, you can see, and then the plotter. This is the output device wherein which many of the architects use. Suppose if the layout is being drawn in using the computers, using some software CAD and CAM, and then these particular outputs can be printed onto the paper. As the printer size are very small, so maximum the layouts which needs a heavy length. So those particular images or else those particular designs can be printed onto a plotter, wherein which you can insert the paper and you can take the printout of heavy layouts. So this is the special device used especially by the civil engineers or else the designers or else the architects. And then we can see the multimedia projector, wherein which whenever you want to give the PowerPoint presentation and the system is connected to the projector, then you can show it onto the screen by using this particular projector. So all these output devices can be connected to the computer, and then these are the means wherein which we can get the output from the computer system. So apart from these particular devices, whatever we had talked about, the main thing that bridges the gap between the user and the computer system is the operating system. So this particular operating system, without the operating system, the whole system is like a black box. So when the operating system is loaded, it takes control of each and every aspect. So it has its own functions. We will learn it in the due course of time. But this particular operating system can be defined as a system software that manages the hardware and software resources of a computer, providing a user-friendly interface for interacting with the system. This is nothing but in simple, you can say it as it provides a kind of environment to use the system. So there are several things attached in the form of input devices, in the form of output devices, in the form of memory, central processing. There are several things needs a kind of manager to manage the whole sequence of operations. So this is the interface, or else you can call this is system software, wherein which it takes control of each and every aspect of the computer system. It provides a user-friendly interface, it interacts with the hardware, it interacts with the software, it provides commands that were being taken from the user to the necessary components of the computer. All these things are being done by operating system only. So you can see this is the abstract view. Whatever the operating system may be, either it is a Windows operating system, it is a Linux operating system, or else Mac OS or iOS, whatever the case may be, this is the simple abstract one can present. That is in the central part, that is the nucleus part. You can take the computer hardware, and then there are on the top layers you have the users application programs. In between these particular things there is a bridge called as the operating system. So this operating system is the main component which, or else main software which provides the interface between the users and you can see with the computer hardware. So without the operating system directly, the user can't directly interact with the computer. So the operating system understands the commands and it passes on the commands in the form of the language understood by the computer given by the user in the form of the command. So then let us study the objectives of the operating system. As I told you, it provides a kind of environment to the user to interact with the computer system. The main goals or else the objectives of an operating system includes ensuring the efficient use of resources, managing the hardware, and offering a stable and user-friendly environment for running the applications. So these are the basic goals of the operating system. Whatever the operating system you may use, but the primary goals of the operating system are the ones that we had explained. So let us see what all the functions that the operating system does. The first and foremost function of the operating system is the process management. So process is nothing but a program in execution is called as the process. So suppose if the program is just residing in the hard disk, we don't call it as a process until and unless we bring it to the RAM for execution. So this particular process management, in this function, the operating system manages the running applications, the multitasking aspect, and the CPU scheduling. So these are the primary functions of the operating system under the process management. When it comes to the memory management, it allocates and manages the system memory for applications. So you may be activating an Excel sheet, the software, and you may be activating the browser. You may be having one particular task which you want to do using the Word package. So all these things have to be brought to the main memory, that is the RAM. Until and unless those particular applications are loaded, you can't work with those applications. So the RAM itself is a huge component wherein which it is divided into cells, and this particular software needs to be allocated and managed using the operating system. So what kind of boundary I need to provide to the word processing, what kind of boundary I have to provide it to the spreadsheet package, or else whatever the case may be. So here the complete memory needs to be managed by the operating system. So what program needs to be brought from the hard disk to the main memory, or else whenever we quit from that particular software, automatically that should be vanished from the RAM, and the space needs to be managed by using certain other, the allocation needs to be done by the operating system to the other tasks. So whole thing needs to be taken care by the operating systems. The boundary conditions and each and every aspect needs to be taken care by the operating system. Then the third function is the file system management. You may be in requirement in order to open a new folder. You may be renaming the new folder, or else you may be naming the new folder, you may be renaming the old folders, or else you may be opening a new file, or else you want to open the existing files. Whatever the case may be, that complete file system management needs to be taken care by the operating system itself. Other thing is the device management. So there are several other devices connected to the system, and the operating system controls and coordinates the I/O devices like the printers, keyboards, and whenever you are inserting the pen drive, that needs to be activated, and it should allow the user to take some sort of input from the pen drive, or else suppose if you are inserting the CD disk, then also it has to interact with that CD disk, and whatever the content that is there inside the CD, that needs to be accessed. So all these things will be taken care by the operating system under the function called as the device management. And then the important aspect that the operating system does is the security and access control. So it will be seeing which particular file is having the access, login name, password, and other kinds of access controls that it has to take care. And then it has to provide the security between the programs, between the files, and even suppose if it is a multi-user system, it has to provide the security between the user to user also. So on the other aspect that it has to take care is the user interface. So it has to provide either, suppose if the operating system is only inclined with the command line, then it has to provide the command line. And suppose if it is supporting the graphical user interface, then the graphical user interface for the user interaction also needs to be provided by the operating system. So you can see the use the functionality of the operating system lies, and if at all there is a non-existent of the operating system, we can just call that particular system as the black box. So after this particular thing, the other aspect that we will be looking into is the classification of the computers. So in this particular classification of the computers, we can classify the computers into 3 different categories. First, based on the size. So depending upon the size of the system, we can categorize the whole computers. And then the second one is based upon the work, or else based upon the processing it does, we can classify it into analog computer, digital computer, and the hybrid computer. And then the third one is based upon the purpose of use, we can classify the computers into special purpose or the general purpose computers. So one by one we will see how this particular classification differs and where they differ. So based upon the size, the first classification is the microcomputers. So quite frequently we use, or else these are available in the form of the personal computers, or we can call them as the desktop computers. So these particular computers are very small in size and are widely used. So in each and every company, in each and every offices, colleges, we use the desktops, and those particular desktops are called as the microcomputers. These particular computers are designed for individual use and includes the desktops, laptops, tablets. All these comes under the microcomputers only. So they are powered by microprocessors and used for general tasks like browsing, running office applications, gaming, etc. So these are the daily use computers, wherein which most of us we keep it in the houses also in order to perform certain simple tasks that do general tasks like the browsing and other kinds of things. Then comes the next computers model, that is the mini computers. So these particular computers are larger than the microcomputers, but they are very much powerful than the microcomputers. These are designed for tasks requiring more processing power, often small to medium sized organizations. So they may be helpful whenever they are placed in some office like some multinational company, or else in the universities, colleges, etc. So they can support multi-users, commonly used for departmental applications, data management, manufacturing, process control, and scientific research in laboratories. So this is the second classification next to the microcomputers. And then we move on to the other classification called as the mainframe computers. So these are very, very large computers, very powerful systems, and used by large organizations for bulk data processing. So they may be used in banks, government institutions, or else insurance companies and other companies, wherein which bulk data processing is the basic functionality of the company. So they can handle hundreds or thousands of users simultaneously, making them suitable for enterprise level applications. So these are the very powerful systems when compared to the microcomputers and the mini computers. So this is the main powerful computer that one can use in order to handle the bulk data processing. Then apart from these, the highest in this particular category is the supercomputers. The fastest and most powerful type of computers designed to perform high complex computations at extremely high speeds. So these are the supercomputers. Like if you want to do the climate modeling, weather forecasting, scientific research, cryptography, AI applications like nuclear simulations and other kinds of things. So for all these kinds of applications, we use the supercomputers. So here the main underlying thing that one needs to look into is the intensive computational power. So all these applications needs intensive computational power. So here the supercomputers will be the computers used for such kind of applications. If you take the case of computers which are classified based on the how they process the data, they are divided into 3. The first one is the digital computers, second one is the analog computers, and the third one is the hybrid computers. So the name itself says that the digital computers are meant for the format like it supports the binary formats like zeros and ones, and it performs the calculations and logical operations using discrete values. Discrete values in the sense 0 or 1. So high accurate and reliable for storing, processing, and transmitting the data, and they are very much capable of handling large volumes of data with high precision. As it works with the discrete values, it gives the high precision. It gives it gives the capability of handling the large volumes of data with high precision. So the next thing that under this category is, like for these particular computers, the applications we can mention are they are used in data processing, office work, gaming, and communication. So these are employed in scientific research companies, engineering companies, and software development companies, wherein which the computations are done using the discrete values. And the second thing is the analog computers. As the name itself suggests that it receives a kind of continuous signals. So it processes the data in continuous signals and physical quantities such as voltage, pressure, and temperature. So in order to work with these kinds of continuous signals, you don't require the digital computers. However, there is a necessity of doing the taking the input as the continuous signals. So here the requirement is the analog computers. So they are very much effective in the simulating real world systems and handling the continuous data. So when compared to the digital computers precision, these are less precise, and then they are basically helpful for the real-time calculations. So streaming of data is coming into the computer in the form of continuous signals. Obviously, the analog computers make an impact, and then for the real-time calculations basing upon the continuous signals, these will take care the analog signals. So these will be used in scientific and engineering applications for simulating systems like weather forecasting, fluid dynamics, and electrical circuits. These are the three examples I had quoted here. And then these are very much common in medical equipment. Like whenever you go for the imaging kind of thing or some sort of diagnostic kind of thing, where in which these particular computers are very much helpful there, that too taking input as the analog signals. So these are employed in control systems such as automatic aircraft and industrial process controls also. So and the typical character of the next category is hybrid. Hybrid itself, the name itself says that both the components are present in the hybrid computers, the digital component as well as the analog component. So the analog components handle continuous data, while the digital component process the discrete data. So in order to support both kind of the continuous signals as well as the discrete values, these hybrid computers are very much used, and they offer both real-time processing with a high precision. So these are the devices to be used whenever you require and whenever you want to take the input in the form of continuous signals or else in the form of the discrete values. These particular computers are used in complex medical applications such as monitoring and diagnosing patients in ICUs, applied in industrial control systems for real-time processing and precision control, and these are used in the defense systems, space exploration, weather modeling, and for simulations and other kinds of complex activities. So these particular things, basically whenever you visit an ICU in a hospital, basically the devices, whatever that they are working are the computers, and those particular computers comes under the category of hybrid. So basing upon the purpose of use, the computers can be classified into general purpose computers or else the special purpose computers. So general purpose computers are designed to perform wide range of tasks and applications. They are capable of running various types of software programs for different purposes, highly flexible, and can be programmed for multiple users without hardware modifications. Some of them you can categorize them as desktops, laptops, smartphones, etc. And then these particular things can be used for any kind of general software or else general applications. However, when it comes to the special purpose computers, these particular special purpose computers are designed to perform a specific or specialized task. So it may be a kind of embedded device, or else it is optimized for one particular function, a specific function leading to higher efficiency in that particular domain. So typically not flexible or reprogrammable beyond their particular capability. Suppose if it is been programmed for certain tasks, it would be functioning only, it would be suitable only to like execute that particular task only. So it can't be generalized. We can't generalize these particular computers, and we can't reprogram these particular computers, and whatever we want to do, we may not be in a position to do with the general with these special purpose computers. However, for those reasons, we can use the general purpose computers. These special purpose computers are having the applications in automotive control systems, ATMs, household appliances like washing machines, micro ovens, and other kinds of things, wherein which the certain embedded device like embedded chips in the form of computers will be available, and they are meant to do only specific tasks controlling the thing like the industrial control systems, the military operations, ATMs, etc. So these are employed in scientific research for simulations and in robotics for specific tasks like navigation or control also. So in this particular session, we had studied some essential components which are required for taking the input to the system. Those are the input devices. And then we had studied about the output devices to take the outputs in the form of printing, in the form of viewing it onto the monitor or viewing onto the projection. So those particular things we had studied. Apart from that, we had studied an important system software called as the operating system, which is the system wherein which it provides a kind of interface between the user and the system to execute the jobs what the user intends to. So after that, we had studied about the classification of computers basing upon the size, basing upon the work, basing upon the purpose. We had categorized all the computers, and then we had studied one by one all the computers. So with this particular session, we had come to an end to the unit 1 of BEY 020 and BCS 011 and BCS 111. And in the next sessions, let us concentrate on the second unit. With this, I'll take leave. Wish you all the best.